The name MATLAB comes from a portmanteau of matrix laboratory. So you should think of matrices as the fundamental building block of MATLAB. In this video, I'll demonstrate the important basics of working with matrices. So let's create our first matrix. I'm going to call this M, and we'll make it equal to 1, 3, 7 for the first row, and then we put our semicolon, then specify the second row, let's say 4, 7, 11, and our third row, this will be a 3 by 3 matrix, 4, 6, 17, 13. I'll close it and hit enter, and it shows my 3 by 3 matrix and the corresponding entries. Now I can access an individual entry by typing M, and let's say row 1, column 2, which should return 3. And I can do the opposite, row 2, column 1, which returns 4. So 4 and 3 in the previous answer. So it looks good. Now I can do things, I can operate on it. I can do something like M times M and multiply the matrix by itself. Now, shorthand for this would be M caret 2. So let's M as a matrix to the power of 2. It gives me the same answer. Now, what happens if I want to operate element by element or element-wise? Well, I could do M period and take the power of 2. So this will operate on each individual element in the matrix. So it's a much different answer. And obviously you can do other things like 1 dot divide M. So it'll take the reciprocal of each element in the matrix. And most operations work that way. So always remember the period makes for an element-wise operation. Now there's the handy I function, so EYE, like your I, but say I3 will create a 3 by 3 identity matrix. So with 1s on the main diagonal. So let me set that to a variable I3. Now if I multiply M times I, it should give me back the matrix M, because anything times the identity just gives back the original matrix. And that seems to work fine. I can also take the inverse of my matrix with the INV function. So an inverse of the matrix M gives me this matrix. I can also take its trace, so the sum of its diagonal elements, the rank of the matrix M, which should be 3 if I've chosen it correctly. So if the rows and columns are linearly independent, it will have 3. If there's a dependency of one row or column, it will show something less, like 1 or 2.